The next presentation should be from Elena Matroana Hreciuc. I cannot pronounce this name, and it's about Terraforming Mars project. And I suspect that she has recorded it. So Gustavo is sharing. Thank you, Gustavo.
To present the project Terraforming Mars. This project was coordinated by me, Elena Matroana Hreciuc, and developed by students Apoloteanu Denis, 13 years old, from secondary school Ioan Creangă in Suceava, Romania. This project was participated in the Researchers' Night European event and the Reconnect contest, propose a space mission, and gain first place in this contest. The Earth, our cradle of life for over 400 million years, now faces existential threats like environmental damage, resource depletion, and the sun's eventual expansion. These challenges necessitate the search for alternatives beyond our planet, and terraforming Mars, with its surface oxygen, solid water, and essential minerals, presents the best option. Mars similarities in day length and vital resources enhance its potential as a new home. As life once emerged from the oceans, it now reaches for the stars, with Mars as our next frontier. Terraforming Mars is our bold solution, me and my student, for a sustainable future beyond Earth. The terraform stages includes developing magnetic field, melting stars, exporting nitrogen, introducing phytoplankton, creating fertile soil, and stabilizing the ecosystem. Technological and logistical considerations, the second part of our idea. This covers the required advanced technologies, potential costs, risks, and duration of the terraforming process. My students' vision for terraforming Mars is a complex, long-term endeavor with significant costs and risks, but offers a promising solution for humanity's future beyond Earth. And our first solution uses a Martian core to generate a magnetic field through chemical and physical processes. Mars has extreme temperature variations, a thin carbon dioxide atmosphere, and low gravity. Its core, composed mainly of iron, nickel, and sulfur, could be utilized to create a protective magnetic field. The second solution, deploy a satellite at the Lagrange 1 point to generate a magnetic field as proposed by NASA. This would shield Mars from solar wind and cosmic radiation, helping retain a thicker atmosphere and protect future habitats. Melting the planet is crucial because Mars contains oxygen trapped in materials like iron oxide and carbonate, which also impart its characteristic color. Releasing this oxygen requires heating to around 5,500 degrees Celsius and daunting tasks simplified by a colossal laser. The world's most powerful laser at 10 petawatts falls short. We need to double this power. This process aims to form future rivers, lakes, and eventual oceans. Expected outcomes include 100% oxygen, 0 nitrogen, a volume of 1,154 cubic kilometer million of cubic kilometer, 750 kilogram of oxygen per cubic kilometer, 0.2 bar pressure, and an atmosphere of 868 trillion tons, dense and flammable, challenging to breathe. Exported nitrogen is crucial and must coincide with the melting process to ensure stability Balancing Mars' atmosphere requires 3,000 trillion tons of nitrogen sourced from Titan, Saturn's largest moon, as Earth's resources are insufficient. The proposed method involves liquefying nitrogen on Titan, transporting it to Mars, and releasing it into the atmosphere upon arrival. This ensures effective integration into Mars' atmospheric composition, aiding in the creation of a stable and breathable environment. Exporting phytoplankton to Mars is crucial as it initiates the introduction of life, particularly in the form of water. This straightforward process involves transporting phytoplankton from Earth, making the inception of Martian life form, and determining the pace of which habitable conditions for humans can be established. To transform Mars soil into fertile land, we utilize ash left after melting its surface, breaking it down into finer particles with a powerful laser. Adding water to transforms these particles into mud, forming the basis of fertile soil. Mars' low gravity facilitates the growth of large trees with extensive root systems, aiding in converting ash into nutrient-rich soil. This process is pivotal for establishing conditions conducive to supporting terrestrial life in the red planet. Ecosystem stabilization on Mars entails establishing balanced ecological interaction gradually. A rapid life development is possible, but achieving stability takes time. Minor disturbances can trigger chain reaction, disrupting the entire system. In optimal conditions, stabilization could take around 100 years, while more challenging scenarios may require several hundred years. This underscores the delicate nature of ecosystem development, necessitating careful monitoring and management during Mars terraforming. The costs of terraforming Mars are categorized into construction and energy, totaling approximately $4 trillion. Construction costs are measured in billions of dollars, while energy costs are in trillions of dollars. The cost breakdown for terraforming Mars includes estimated satellite cost highlighted in yellow, nitrogen exporting highlighted in gray, phytoplankton in green, as you can see, and laser costs in both graphs for transportation and energy. Terraforming a planet carries substantial risks that must be carefully managed. Nitrogen capsules could be struck and deviate from their trajectory. Desynchronization of melting and nitrogen export could lead to planetary instability. Failure of generating magnetic field, risk of preventing ocean life from forming, potential chain reactions of fertile soil must be controlled to avoid unintended consequences. These risks highlight the importance of meticulous planning and robust contingency measures in terraforming projects. The duration of terraforming operations on Mars is approximate and contingent upon both the minimum requirements and the scale of the operations budget. The timeline for Mars terraforming activities spans several decades. Preparation and generation of the magnetic field, estimated by 2040, nitrogen extraction and export planned from 2041 to 2011, export of phytoplankton scheduled from 2011 to 2013, followed by fertile soil development from 2013 to 2010. Ecosystem stabilization is projected to occur between 2110 and 2210. In conclusion, terraforming Mars stands as humanity's primary endeavor, demanding concerted efforts, risks, substantial resources, and advanced technologies like lasers, generators, and interplanetary transport system. Ultimately, it represents our quest for a new habitable world, a verdant, blue, and volcanic planet welcoming to life. During my and my teacher journey to discover how to terraform the planet Mars, we have encountered incredible challenges and possibilities, such as developing advanced technologies and exploring new horizons to create as future where humanity thrives beyond Earth. This mission is not just about Mars. It is about opening a new chapter in our history and ensuring a brighter future for all. With enthusiasm for the journey ahead, well as a dreamer, Dennis Zaboloteanu. My student want to transmit you some words from his part because he's really enthusiastic um, researcher about creating a new home for our planet. Thank you all. Thank you for your attention, and we hope together, me and Dennis Abolatano, that our idea will be someday in the mind of a real researcher, where my student will be the real researcher who transform Mars into a real new Earth. Thank you again.
Thank you, Gustavo, for sharing the presentation. I think the speaker is still not with us, right?
Oh, I don't see her here.
Yeah, so there's no possibility of asking any question. It's good to
Maybe
know that.
maybe she joins later.
Yeah,
So,
it's good to know there are people seriously thinking about terraforming Mars. There's so much being said now about this new space thing. I heard about this new terminology recently. I didn't know about this. And all the ideas and how economy is shifting greatly, mixing AI and the new space is really mind-boggling. But it's better that we start behaving properly here on Earth before we go explore other bodies in the solar system.
one thing that I missed in this study, which is quite interesting, because if you consider it was made by students, then it's even more impressive. But the time scales, yeah, because
Right.
I understand that this process is not like done in a few years. It
No,
would
not
take
at all.
thousands of years probably for the system to stabilize. Same
Right.
thing with Venus. If like older people like us have read Carl Sagan's Cosmos, and there's a chapter that is about making rain in hell. That was the terraforming of Venus, and is also like several tens of thousands of years before it's might become more hospitable to us. And I don't think we have that much time the way things are going, unfortunately. So even
well, let's
without,
think positively, Gustavo.
yes, we don't have any other option, right?
Exactly.
And it's through education that we can change things. And I think that climate changes, each day that passes becomes more a reality, and people are really starting now to take it seriously because the effects are being felt everywhere. So that might be the push.
The trigger for it.
Yeah.
Well, there are changes. There are many things happening. It's just that they need
Yeah.
to speed up.
Yeah, but again, that's the time scales. It's not going
Yeah.
to change now. It's going to
Yeah.
the effects are still building up, and if you stop all the carbon emissions now, it's going to take many decades
Mhm.
to start slowing the process.
Well, you
So,
never know. Someone might come up with some invention that will speed up the process also.
maybe that shouldn't. From
Exactly,
yeah.
exactly. You don't know. I mean, you don't know where the next hero will come from. You know, they're probably sitting in classrooms all over the world, several of them, and at some point they will be like Greta and say, "Stop it," and come up with solutions and really make the change.
Yeah, there's a comment by
Okay.
Teresa on Facebook that she prefers more investment in restoring their soil and earth problems.
Yeah, that's true, Teresa. Of course, we have to do that. But if everything goes well on planet Earth, we will be too many to live here in any case. We need to learn how to leave our cradle and go explore the solar system and other systems around the universe. But first of all, we need to have our good manners code fixed up and have people, change the way they perceive life and understanding what's the meaning of being humans. Once we do that, then it's safe to think that we will, produce the necessary technology and we will explore and move on. If we are all healthy and living here, we will not fit here. We need some other options, and that is good. That is nice. But we need to learn how to properly contain our egos and self perception, to change the way we perceive our place and role in this beautiful planet. Okay, should we move on, Gustavo?
Yes, please.